Hi, we are going to divide polynomials. This is Unit 2, Lesson 4. So first, is 5 a factor of 20? And how do you know? So yes, 5 is a factor of 20 because 5 goes evenly into 20, or you could do 20 divided by 5 and get a whole number. It's one way of thinking of it. Or we know that 5 times 4 is 20. So yes, 5 is a factor of 20. Is 4 a factor of 33? And how do you know? So no, 4 is not a factor of 33. There's not a whole number we can multiply by 4 to get 33. Or if we do 33 divided by 4, we get a remainder. This would be 8. 8 times 4 is 32, and there's still 1 left over. So 33 divided by 4 is 8 and 1/4. 1 is the remainder. Has a remainder, it doesn't work out evenly, so no. 4 is not a factor of 33. So we're going to use that same concept to talk about factors of polynomials. So is x plus 1 a factor of this polynomial g of x? So to find that out, we're going to take g of x, divide by x plus 1, and see if it works out perfectly or if we get a remainder. So to divide by x plus 1, we're going to use the area model. I'm going to put x plus 1 along the side, and I'm going to try to see if there's something I can multiply across the top to x plus 1 so that everything on the inside of the area model, all these boxes, combine and add up to equal g of x. So I want to figure out what goes along the top to multiply to x plus 1 to get g of x on the inside. So I'm going to take the first term of g of x, x cubed, and put it in the first box. And then I can go along the top and go ahead and fill in my first term of the other possible factor that multiplies to x plus 1, x squared. X squared times x is x cubed. That's why I'm putting x squared there. And then I could do x squared times 1 and fill in that box below x cubed. So x squared times 1 is just x squared. Now I'm going to go to the next term in g of x, and it's negative 3x squared. So what I want to do is put something here in this box to add to x squared so that these two boxes combined add up to negative 3x squared. So it would be negative 4x squared. And then I'm going to go up here and write what multiplies to x to get negative 4x squared. It would be negative 4x. These two multiplied together, we get negative 4x squared. And then I'm going to fill in this box. Negative 4x times 1 is just negative 4x. Okay, so I'm going to go to the next term, 6x, and I want to put something here so that these two boxes, these x boxes, add up to 6x when I combine the like terms. I have negative 4x. I need to figure out what goes here to add to negative 4x to get 6x. So 10x and negative 4x, these combined would give me 6x. Then I'm going to go up to the top and figure out what you multiply to x to get 10x. And then I can fill in this last box. 10 times 1 is 10. And then, it's supposed to be 8, not 10. So this didn't work out perfectly. In fact, what I could do is come up with a remainder. So I would just add another column and figure out, just about following the same pattern we were just doing for the rest of the problem, what would go here to add to 10 to get 8 would be negative 2. And then this would be the remainder. But basically, I can just stop. It just asked if x plus 1 was a factor, and I divided by x plus 1. That's what I did here. I got this so far, and it didn't work out at the end. I got 10 instead of 8. It doesn't work out perfectly. In fact, we get this remainder. So I'm going to say no. G of x divided by x plus 1 has a remainder. So that's why x plus 1 is not a factor. Okay, we're going to try number 4. And it's asking us to take h of x and divide by x minus 3. So I'm going to put x minus 3. I'm going to use the area model again. And I'm going to put the first term in h of x in the first box. It's asking me to take h of x, divide by x minus 3. When you divide by something, that means you're trying to figure out what you multiply to the factor we're dividing by to get h of x. So I'm trying to figure out what goes up here to multiply times x minus 3 to get all of these terms on the inside, which should be the h of x terms. So I put the first term in the first box, and I'm going to go to the top and figure out what you multiply to x to get x cubed. And that would be x squared. And then I can multiply x squared times negative 3 to get negative 3x squared. I'm going to go to the next column, and I'm going to go to my next term, which is actually, there's a missing term here. There's 0x squared in h of x. So for my x squared terms, I need these boxes to add up to 0x squared. I have negative 3x squared. That means I need to put a positive 3x squared here. So now that these add up to 0x squared. Then I can go up above and figure out what to multiply to x to get 3x squared. And now I could do 3x times negative 3, negative 9x, and make another column. So I could keep going to my next term, the x term, 2x. I have negative 9x. I need to figure out what goes here to add to negative 9x, so I can combine these boxes, add them together to get 2x. So these two now add together to get 2x. Now I could go up above and figure out what I multiply to x to get 11x. It would be 11. And then I could fill in this last box. 11 times negative 3 is negative 33. But I don't want negative 33. I want negative 3. So this means x minus 3 is not a factor of h of x. That's okay. It has a remainder then. So I'm just going to keep going and add another column. This is for the remainder. So just like the same pattern that we've just been doing, I'm going to add a number here to add to negative 33 so that it equals this last term, negative 3. So I need to add something here, and that would be 30. Now these two add together to get negative 3. So I basically just kept going, added another number. So now this all works out. So all of these terms combine to get this polynomial. And then this number is the remainder. The way we write the remainder for our answer is we take what we have so far. We have x squared plus 3x plus 11, plus you put the remainder, which for this is 30, over what we were dividing by, x minus 3. So to divide h of x by x minus 3, this is our answer. X squared plus 3x plus 11 plus 30 over x minus 3. Now we want to find h of 3 using synthetic substitution. So this means plug 3 in. H of 3 means if you plug 3 in to h, to the function, what does it equal? But we're going to use synthetic substitution. Synthetic substitution was the one where we put what we're plugging in on the outside of this kind of box thing. And then along the top, we put the coefficients of h of x. I'm going to write out h of x again because I kind of circled some stuff. So h of x is x cubed. And I'm going to fill in this missing term, 0x squared plus 2x minus 3. So that's h of x. We put the coefficients of h of x along the top. So there's 1x cubed, 0x squared, 2x minus 3. So that's how you set up synthetic substitution. And the way you get all these numbers, you go through the whole thing, is you bring the first number down, and then you multiply to the number on the outside, the 3. So 1 times 3, 3. And then you add 0 plus 3, 3. Multiply. Add. Multiply. Add. So h of 3 is 30, because that's the number we just got at the end. The reason you're doing this is there's a relationship between these numbers and what we just did over here when we divided by x minus 3. If you see these numbers, 1, 3, 11, 30, those were the same numbers that were here. 1x squared, 3x, 11, and 30 for the remainder. So this is actually another way we could have divided instead of using this is the area model over here. We could use synthetic substitution. So what we could have done is to divide x minus 3. You can switch the sign, put a 3 on the outside. And the reason you do that is if x minus 3, if that's what we're dividing, we just kind of set that equal to 0. Actually, I'll put equal 0. And x would equal 3. So that's how we're getting the 3 on the outside here. So if you're dividing by a 1x plus or minus a number, you can set that equal to 0 and put what x equals here and use synthetic. These numbers along the bottom help you write your answer. So 30 is the remainder. And then this is the just the constant, has no x. This is the x term, and this is the x squared term. And you can just like write out your answer like that if you were dividing. Okay, we're going to do number 5. So we want to do f of x divided by x minus 2. So I'm going to do the area model again. Use the same colors I used on the last one. So switch it to purple. All right, so x minus 2 is what we're dividing by. We're putting that on the outside. We put the first term in the first box, x cubed. We go to the top and figure out what to multiply to x to get x cubed, and that would be x squared. And then we can fill in the bottom box, x squared times negative 2, negative 2x squared. And we're going to go to the next column and look at the next term, the x squared term, negative 10x squared. I have negative 2x squared so far. I need to figure out what to add to that to get negative 10x squared. Then I'm going to go to the top and figure out what to multiply to x to get negative 8x squared. Negative 8x. Negative 8x times negative 2, negative 16x. And then I can go to the next column, and the next term I want 31x for the x's. I have, this should actually be positive 16 because it was a negative times a negative. I have positive 16x right now. So I need to add 15x so that these two add together to get 31x. Then I'm going to go to the top and figure out what to multiply to x to get 15x. And then 15 times negative 2, fill in this last box, negative 30. And do I need to keep going and add a remainder? No, because I had negative 30 as the constant, as the last number, and I got negative 30, so this worked out perfectly. And this would mean that this is just my answer. There's no remainder. X squared minus 8x plus 15. I don't need to keep factoring because all it's saying is just to divide those two, and this is what I get when I divide. And that also means, it's not asking this, but that also means that x minus 2 is a factor of this polynomial because it went into it perfectly. There was no remainder. Now we're going to find h of 2 using synthetic substitution. Actually, it should say f because it's still talking about this, f of x, not h of x. So I'm going to change that to an f. Okay, so find f of 2. So we put 2 on the outside. And then we put the coefficients of f of x along the top. So there's a 1x cubed, negative 10x squared, 31x, negative 30. We bring the first number down, and then we multiply to the number on the outside. 1 times 2 is 2. And then add, multiply, add, multiply, and then add. Okay, so if it's just asking for f of 2, that equals 0. That's the number we got at the end. That's answering this question. Find f of 2, it's 0. But notice like in the last problem, the whole reason I had you do this was to point out that when you are dividing by a factor, x minus 2, if we plug in 2, we can use these numbers in synthetic substitution. We can use these numbers to actually just get what we would divide if we divided by x minus 2. You have the 1x squared minus 8x, and then plus 15, and then there's no remainder. So we could actually, instead of dividing using the area model, we could have actually done this problem by using synthetic substitution, and then just seeing that there's no remainder, and then kind of building our answer from there. 15 and a negative 8x and a 1x squared. Also, since we were saying x minus 2, I was saying earlier x minus 2 is a factor of f of x because it went into it perfectly. There was no remainder. Then that means if x minus 2 is a factor, then 2 is a root. And when you plug in a root into a function, you always get 0 at the end. Okay, we're going to do one last one. 2x plus 3. We're dividing this whole thing by 2x plus 3. I'm going to do the area model, and then this is just to review kind of the area model again. And I think in this one we get a remainder, so kind of to review how we write the remainder or how we get the remainder. So we're dividing by 2x plus 3. And by the way, on the last ones, I was just explaining that instead of using the area model, I could use synthetic substitution, but that only works if you're dividing by a 1x plus or minus a number, because then you just set that equal to 0, and you get what the root would be. That's what you plug in. So if it's x minus 2, you put a 2. If it's x minus 3, you could put a 3 and use synthetic. This one, it doesn't quite work out the same way because there's a 2 in front of the x. So we have to use area model for this. All right, so I'm going to take the first term, put it in the first box. Then I go to the top and figure out what multiplies to 2x to get 2x cubed. And then I fill in the bottom box, x cubed times 3, 3x squared, or x squared times 3, 3x squared. Next column. And next term, x squared. So I want these two boxes to combine and add up to x squared. Right now I have 3x squared. So I would need to put a negative 4x squared there so that these two combine to get a positive 1x squared. That's not right. I want positive, so I need a negative 2x squared. So that these two combine to get a positive x squared. So then I can go up here, and this would have to be negative, I'm trying to think of what multiplies to 2x to get negative 2x squared, negative x. And then negative x times 3 is negative 3x. I can go to the next column. And the next term, negative 9x. I have a negative 3x so far, but I want these two to add up to be negative 9x, so I need to put a negative 6x. And then I could go to the top and figure out what multiplies to 2x to get negative 6x, negative 3. 3 times negative 3 is negative 9. And then I go to the last term and see if it's negative 9. It's not, so I need to keep going. I want it to be 5, not negative 9. So that means there's a remainder. I need to figure out what goes here to add to negative 9 so that I do get the 5 at the end. 14. So now I've forced it to work out. Basically, 2x plus 3 is not a factor of h of x because we divided by it. It didn't work out perfectly. We need to add something to make it work out so that I get a 5 at the end. And that number that we add to make it work out is the remainder. The way we write our answer is x squared minus x minus 3 plus, you put the remainder over what we were dividing by, 2x plus 3. Okay, last thing at the bottom is just to kind of summarize a couple things that were mentioned earlier. How can we know that x minus a is a factor of a polynomial that we're calling p of x? Well, if we divide p of x by the factor, the potential factor, x minus a, if we divide them, if it is a factor, it'll work out perfectly with no remainder. If we divide p of x by x minus a, and there's no remainder, that's how we know that x minus a is a factor of p of x. Another way, actually, to figure out if it's a factor is if it was a factor, if x minus a was a factor, then that means x equals a would be a root. So here, actually, I'm going to write that up here. If x equals a was a root, when you plug it in, you get 0 at the end. That's what happened here. X minus 2 was a factor. We didn't get a remainder. It worked out perfectly. If x minus 2 was a factor, x equals 2 is a root. And when you plug in 2, you get 0. So another way to do it is if p of a is 0, then that means x minus a would be a factor. How can we know that x equals a is a root? And that's kind of what I was just saying here. If you plug it in, p of a, and you get 0. And that's how you know that x equals a is a root.